Welcome to the deep dive. Today we're tackling a really common headache, I think, for a lot of network folks.
Yeah, what's that?
Automating older optical line terminals, OLTs.
Right, the ones without the nice modern APIs.
Exactly. The ones that lack things like TR069 or, simple REST interfaces. Maybe you listening are managing a network with this kind of legacy gear, or maybe you're just interested in some clever tech workarounds.
Well, either way, this should be interesting. We're going to unpack how you can actually use smarts to get around these limitations.
We've been digging into our sources,
Yeah.
and our main one today is this really insightful Nepali podcast episode. It's called EP.02, Legacy OLT Automation, API Bina Automation.
Which basically means automation without API. Perfect, right. It features a host talking with a network automation expert, really getting into the nitty-gritty.
So our mission here is to pull out the core strategies, maybe some surprising facts, about how you actually automate these older OLTs when they don't have those standard modern hooks.
Right.
Okay, so let's start with the basics. What's the biggest hurdle with these legacy OLTs?
Well, the fundamental problem is just that lack of open, standard ways to talk to them automatically.
Right.
These older models, and the podcast specifically calls out some big names Huawei, especially their MA5600 series,
Okay.
ZTE, like the C320, and FiberHome's AM5006. They just weren't designed for the kind of automation we expect today.
So no easy rest calls, and even TR069 might be switched off.
Often, yeah.
Yeah.
It makes it really tough for operators trying to speed up things like, setting up new customers or just checking network health. It's like trying to manage your smart lights with a dial-up modem.
Yeah, good analogy.
Yeah.
So you can't just fire off a clean command. But the expert in the source, they were pretty optimistic, weren't they? Automation isn't totally impossible.
Not at all. And that's the fascinating part. Even though they lack the new stuff, these old boxes do support older, more established protocols. And you can get really creative with those. It's about finding like a different dialect the OLT still understands.
Okay, so if the shiny new APIs are out, what's in the toolkit? The podcast mentioned a few key things. Let's start with SNMP, Simple Network Management Protocol. Most have probably heard of it, but how does it help here?
SNMP is kind of the workhorse in this scenario. The podcast really stresses using the get and walk commands.
Right.
These let you pull a surprising amount of key info from the OLT. We're talking ONU status, the boxes at the customer end, port details, traffic numbers, even things like the OLT's internal temperature.
Okay. That's actually more visibility than I might have guessed, so you can get a decent picture of what's going on.
Definitely.
But SN and key traps also came up. That sounds more proactive.
Exactly. Traps let you set up real-time alerts. So instead of constantly asking the OLT, are you okay? Are you okay? The OLT can tell you when something specific happens.
Like what?
Well, the podcast gives a great example. An ONU down trap. If a customer's ONU drops offline, the OLT can send an SNMP trap. And that trap message can trigger something else, like automatically sending an alert email to the network team.
That's pretty neat. Instant notification for key problems. Okay, so SNMP gives us eyes on the network and some basic alarms. What's next? The podcast mentioned SSH and Telnet. That feels more hands-on.
It is, yeah. SSH, Secure Shell, and Telnet let you log into the OLT's command line interface directly.
CLI, okay.
And this is where scripting is absolutely key. The podcast talks about several ways to do this. Python, using a specific library called Paramiko.
Paramiko, okay.
Think of Paramiko as like a toolkit in Python that lets your script talk SSH to the OLT securely. Or you could use Node.js with its SSH2 library, or even older tools like expect scripts. And then there are higher level things like Ansible too.
Right, Ansible.
Basically, these tools let your script send commands to the OLT, just like an engineer typing them in, but automatically.
Got it. So we're automating the typing part. What kind of tasks can you actually automate this way? Seems pretty flexible.
Oh, it's surprisingly broad. The podcast mentioned key things like binding a new ONT to the OLT, setting up service ports, applying LAM profiles, that's the internet connection stuff, configuring VLAN tags for separating traffic like internet, voice, TV, and even pushing TR069 settings to the ONTs, assuming the ONTs support TR069 themselves.
Wow, okay. So you could potentially provision a whole customer service internet, phone, maybe TV, just by running a script that logs in and types the right commands. That's a big step up.
It really is.
But I imagine the output from a CLI isn't always, neat and tidy. It's just text, right? How do you make sense of that automatically? That's command parsing.
Exactly right. Command parsing is critical. because you're dealing with raw text output from the CLI. So the podcast explains how you write scripts that can sort of read that text, find the important bits of information.
Like pulling out an IP address or a status.
Precisely. And then convert that useful data into a structured format, like JSON.
Ah, JSON. Much easier for computers to handle.
Yeah. Once it's in JSON, you can easily stick it in a database or feed it to other systems like an auto configuration server, an ACS.
Okay, so you're basically translating the OLT's messy text into clean, usable data, like a translator for old gear. Now, one of the big goals here must be plug and play, right? Getting new devices online easily. How does automating ONT registration work with these older OLTs? This sounds tricky.
Yeah, this is where it gets quite clever. The podcast outlined a workflow that uses the OLT's auto-find feature, if it has one.
Oh, okay, auto-find.
So you configure the OLT to automatically notice when a new unconfigured ONT pops up on a port. Then you have a script that runs regularly, maybe every few seconds or minutes.
What does the script do?
It logs into the OLT and runs a command like show on autofind all or something similar. It checks if any new ONTs have appeared.
And if it finds one?
It grabs the ONT's details, usually the ANSI address and serial number. Then it checks those against a database, maybe a list of ONTs you're expecting or have pre-authorized.
Ah, validation step.
Exactly. If it finds a match in the database, the script then automatically runs the commands to bind that specific ONT to the correct port on the OLT.
Okay, that's sufficient. Just
Yeah.
getting it recognized. But it gets better, doesn't it? The podcast mentioned automatically applying the actual service profiles, too.
Absolutely. Binding is just step one. Once the ONT is bound, the script kicks into high gear. It automatically applies all the necessary configurations,
Like what?
like the WAN profile for internet, the TR069 settings for management again, on the ONT itself, any PPPoE details if needed, and the VLANs for different services like voice or IPTV.
The whole package.
The whole package. And the really impressive part, this whole sequence from the OLT seeing the new ONT to it being fully configured with all services happens automatically via that SSH or Telnet login. And the podcast claimed it could happen super fast,
Great.
within 5 to 10 seconds.
Whoa, 5 to 10 seconds. Really? That sounds
Oh,
almost
well,
too good to be true. What might slow that down in reality?
That's fair. Things like network lag, how busy the OLT processor is at that moment, maybe how complex the configuration is. Those could add some delay.
Sure.
But the point is, even if it takes 20 or 30 seconds, it's still incredibly fast compared to manual work. In a good setup, that 5–10 second range is achievable. Imagine the tech just plugs in the ONT at the house and bam, before they've even packed up their tools, it's configured and online.
Yeah, that's a massive time saver and cuts down on errors, too.
It's a huge win.
Okay, so we've got SNMP for monitoring, SSH scripting for control, parsing for data, but then there's this idea of building a custom API layer on top. That sounds like taking it to the next level. How does that work?
Yeah, this is really about abstraction. You build a sort of middleware system.
Okay.
This middleware knows how to talk the old languages, SSH, Telnet, SNMP, to the legacy OLTs behind the scenes. But to the rest of your network systems, it presents a nice, clean, modern interface, usually a JSON REST API.
So it hides the old clunky stuff.
Exactly. It makes the old hardware look like it has a modern API. It's a way to bridge the gap without replacing the OLT itself. It's kind of future-proofing on your own terms, making your operations less tied to specific vendor hardware.
Right, you're decoupling things. Can you walk us through an example? How would this custom API actually be used?
Sure. The podcast gave a good one. Imagine you have an endpoint, like a web address, maybe a POLT register on it.
Okay.
You'd send a POST request to that address, and the data you send the payload would be JSON. It would contain everything needed, the ONT's MAC address, which PON port it's on.
PON being passive optical network.
Right. And the profiles you want, internet, TR069, PPPoE, username, password, etc.
You just send that one clean API request.
On the back end, that API call triggers a script on your middleware server. That script then does the dirty work, logs into the right OLT via SSH or Telnet, runs all the necessary CLI commands based on the JSON data it received. And once it's done, it sends back a simple success message through the API. So to whatever system made that initial request, maybe your provisioning portal, it just looks like it talked to a modern API-driven device.
That is really clever. But what about building that middleware? What do you need to think about? Development, security?
Oh yeah, crucial points.
Yeah.
Development-wise, you need people who understand both the OLT's CLI quirks and modern API design. Security is massive. You're essentially creating a new door into your OLTs so that middleware needs to be locked down tight, and how it stores and uses OLT login details needs careful handling.
And maintenance.
Ongoing maintenance, absolutely. Keeping the middleware patched, making sure it still works if the OLT gets a firmware update, and having really good logging so you can figure out what went wrong if something breaks. It's not trivial, but the payoff can be huge.
Makes sense. Now, one point that came up was TR069. Even if the OLT itself doesn't support it, the podcast said you could still get the ONT talking to an auto-configuration server in ACS. How does that work?
Yeah, the key thing to grasp here is that TR069 capability needs to be on the ONT, the customer device, not necessarily the OLT in the middle.
Yeah.
So if your ONTs support TR069, those SSH scripts we talked about can push the initial vital settings onto the ONT itself.
Like what settings?
Things like the basic WAN setup, maybe a specific management VLAN it needs to use, and definitely the URL of your ACS server, plus any authentication details it needs.
Got it.
Once the ONT has those key pieces of information, its own built-in TR069 client can then reach out over the network, find the ACS, and register itself.
And the OLT just passes the traffic along.
Pretty much.
Yeah.
In that model, the OLT is just acting like a simple layer 2 bridge. It connects things, but doesn't need to be deeply involved in the management conversation between the ONT and the ACS.
Which means it's less dependent on the OLT vendor,
Yeah,
right?
exactly. Big advantage. As long as the ONT speaks TR069 and can get an IP address, it can talk to the ACS, regardless of whose OLT is sitting in the middle.
That vendor independence is always nice. Okay, to kind of bring this all home, the podcast shared a real-life example, didn't it? The aha moment.
Yeah, this really shows it working in practice. They described an ISP that was actually doing this. They had Huawei MA56683T OLTs.
One of the models mentioned earlier.
Yep, and they were using FiberHome HG6145D ONTs at the customer end. They built their automation server using Node.js with MySQL and Redis databases in the background to keep track of everything.
Okay, standard web tech stack.
Pretty much. And get this, they even integrated a custom Telegram bot for kicking off the provisioning.
A Telegram bot. That's kind of cool and very user-friendly for the field techs, I bet.
Right. So what was the result? What did this setup actually achieve for them?
Oh, the results were apparently quite stunning. They got it down so that a near ONT, once plugged in at the customer's place, would automatically configure itself and register with their ACS in about 30 seconds.
30 seconds. That's incredibly fast.
Yeah, it massively cut down the time to get a customer online. Huge efficiency gain, much better customer experience right out of the gate.
And beyond just speed, think about the agility that gives the ISP. They can roll out services faster, scale more easily, all without being totally bottlenecked by manual OLT configuration.
Absolutely. 30 seconds really drives home how powerful these workarounds can be, even on gear that's not brand new.
Okay, so as we start to wrap up here, what's the main thing you want people listening to take away from this deep dive?
I think the core message is, don't write off your legacy OLTs just because they lack modern APIs. Complete automation is possible. Takes some creativity, yes, but by using the tools that are available, SNMP, SSH, Telnet, combined with smart scripting and maybe that middleware layer, you can absolutely achieve significant automation. You can get real improvements in how efficiently you run your network and deliver services.
It really comes back to that hacker mindset the original podcast mentioned, doesn't it? Finding clever ways to make the tech you have do more. Precisely. Not just accepting limitations, but thinking, okay, how can we work around this?
Right.
And that leads to a final thought, really, for you listening. Think about this approach more broadly. Where else in your tech world do you have older systems with limitations? Could you apply similar thinking? Could you build a modern automation layer using older protocols for other legacy gear? How could mixing old and new unlock efficiencies you haven't even thought of yet? It's about seeing the potential value even in older infrastructure.